So back again with the Grenadier's HVAC box. What I'm just going to look into here is how it's wired. It's pretty simple, as I've probably mentioned before. This is the only connector to the HVAC box. It has 8 pins on it. 2 black wires. One is the negative feed for the actuators, and one is the negative or ground to supply the 3 temperature sensors. Obviously you don't want to share a ground for those. The red wire is the positive for the actuators. The white wire is basically in a loop. So there's 2 white wires and they loop round in a sort of circle, going to each actuator and then passing on to the next one. So those are the signal wires to indicate which actuator should run at any particular point, and also provide feedback as to the state of the actuators to the control unit. And then you've got a blue wire, which is the upper temperature sensor. So there's a little temperature sensor at the top of the unit next to the face vent output, which is basically here. And then you've got a pink wire, which is the lower temperature sensor next to the foot well output, which is obviously this big output here. And then finally you've got the evaporator, I guess like frost up, ice up switch thing, which probably may even control the compressor. But obviously if the evaporator ices up, then you want to turn the compressor off. So that just plugs in there with its little grommet. And that is the green wire. So that represents all the wires. Really not particularly complicated. We've got the 3 actuators here. There's actually 4 in total. There's another one just hanging down on its wire. As you can see, each actuator has a red and a black wire, positive, negative, and then also the white control wire as well. Now these actuators all have basically the same underlying part number on, not the same Ineos part number, but they are clearly all the same part, the same generic part, which I assume and know that they are used in many different vehicles, so pretty generic. They are given a part number by Ineos because I would imagine that they are specifically coded. So they're given, you know, an ID number, which then allows the HVAC system to control any particular one. So if you were going to replace them with a generic one, you presumably have to find some way of actually coding them to match the one that you replaced. And this is the foot one. So they're the actuators. There's 4 actuators in total. 3 of them control the flaps and 1 controls the water valve, which I've obviously mentioned before. This is the water valve removed. The one thing I find slightly odd about the water valve is that the actuator cog doesn't engage the full length of the shaft, which to my mind doesn't seem to be perfect. So if you try and put this on here, reassembling it with one hand, kind of stupid, right? It doesn't go on that far, which possibly could lead to issues in the future. But anyway, we'll see. They are pretty strong. Now inside the actuator you have a control circuit with a motor and so on. And those are the 4 input wires. Little microchip circuit there. Goodness knows what goes on underneath that. And then there's a series of cogs here. Quite a number of them with some extremely fine teeth, as you can see there. It's quite easy to disassemble these because they're just literally clipped together. So if you're careful, you can just remove the clips and off they come. I mean, they're in my opinion, they're not badly made, but obviously there is a lot of coggage in there to go from presumably a fairly high speed motor to providing a high torque output. I guess 1 or 2 of those teeth could fall off and that would be game over, but not sure how often that really happens. So that is basically it. Now it's becoming more and more a pile of bits. Oh, nothing is broken on this. I could actually reassemble it and put it into another car. So that is that for this video. Bye for now.